All right, welcome to video number 2, or the first video that has things that apply to that worksheet that you're going to have to fill out about the evidence of evolution. There's a lot of pieces of evidence. This video is only going to be about the fossil record, as you can see. We can't go back in time, but we do know about things that happened back in time because we have clues, fossils, right? When there's a big old bone, that we dig out of the ground, that bone had to come from somewhere, and we can use those bones as like puzzle pieces to arrange, just like you did in that Communalcule poster, right? We can use it to connect all the dots between the past and the present. Fossils come in a lot of different shapes and forms. We're all familiar with bones, skulls, leg bones, and such. But we have fossil pieces of wood, right? Petrified wood, we call it sometimes, but it's not as common. But we can get logs that have turned into rocks, into fossils. Every once in a while, an actual animal will get stuck in something called amber. Amber is actually tree sap. They get stuck in the tree sap, and then the tree sap turns into a fossil, and the animal that's in there gets preserved. We have imprints of things. Soft tissues don't turn into fossils very well, and so that's why bones are the big one that we find. But plants like this leaf, they don't have bones, and leaves don't have wood that could turn into petrified wood. But in this case, a piece of a leaf got pressed between some layers of sedimentary rock, and it leaves this indentation that we can see what a leaf looked like from a long time ago. And so we have tons and tons and tons and tons of fossils. And of course, we're still digging them up as we speak. Well, maybe not right this moment. Although maybe being out in the middle of nowhere is the best place to be right now, looking for old bones. But our view of the past is always getting better. And our stories, therefore, are getting better. And so one example that we can show here is a cladogram of the elephant family, right? And we have a lot of fossils for these kinds of organisms, right? Not so many down here, but the fossil record is not complete. We're limited to the things that we randomly find. And even though we go out looking specifically in places where we think we'll find them, we never know what we're going to find. And so sometimes there are gaps in what we know, but hopefully we'll eventually find fossils. And so a great example of this is whales. Seems like we're not going to get to do the activity about whales. So we'll just talk about whales. Scientists had this idea that whales came from something that looked like that, this dog-looking thing, for a long time ago. And of course, when you say that a whale came from some sort of dog-looking thing, that's a pretty big claim to make. Nobody would normally just believe that. And so people ask something called, what are the transitional fossils? Where are the proof that these things existed? And so scientists, paleontologists went out and started to find all these fossils. And so each one of these particular pictures over here represents fossils that they found that they have dated to find the chronological order. And then when you arrange them in a chronological order, they have a progression of this dog-looking thing that a little while later still looks like a dog-looking thing. But then it's not a huge leap to get the next thing in line. And that next thing in line is called the Ambulocetus. And this is a pretty important one because it's the first one that shows the change in their body structure, to have the legs in the back start to change, so that its posture changes, so that it can end up kind of living in the shallow, swampy areas at the edge of the water. And it kind of looks like an alligator, and we would think that it kind of probably lived like an alligator, where it would be kind of sneaking around in the shallow areas and then jump out at anything that was getting close. Over time, the legs got smaller and smaller and smaller and smaller until they eventually disappear. Meanwhile, the body's getting more and more streamlined from one step to the next. And we have a whole bunch of fossils. Let me move that out of the way for a second. That represent this, right? Like the pictures here are not just people drawing things. Like for every single one of those pictures, we have a skeleton that lived a long time ago that actually existed, right? And so fossils tell us the story of how whales came from land mammals, which is, I think, very interesting. Of course, to go the other way, where did all the land animals come from? There had to be some sort of fish type thing that eventually made it onto land. And so scientists went out looking for rocks that were a very particular age, the age that would have corresponded to the time period between where fish existed and the first amphibians existed. And they found this exact fossil right here, which they named Tiktaalik. Oop, that's not what's supposed to happen. Tiktaalik over here, which is an Eskimo word for the missing link, right? And it's a fish, has a fish head, has a fish body, but down here in its arms, it has wrist bones, right? And I've never seen a fish that has wrist bones. That's weird. It must have helped the animal live somehow or another. And so this part of the picture right here is trying to show that it might have used its wrist bones to push its head out of the water, right? So most of its body stays in the water, but it can actually come out partially out of the water and use its tiny little wrists to hold itself up, at least for a brief amount of time, right? And so the ability to come on the land when there was no other land animals would have been this huge niche that would have been open, an opportunity. And so having wrist bones would have added to the advantage for survival, and then led to better and better wrists, which led to better and better arms, which lead to actual limbs, legs, probably not arms. I guess it's hard to tell the difference at some point. But in any case, this is a fossil that helps support the idea that land animals came from the ocean. The last one here is the transition from dinosaurs to birds. That birds are actually classified as dinosaurs now. That when the dinosaurs went extinct, not all of them went extinct, and the small ones in particular that probably had feathers turned into birds. Of course, that was just a hypothesis for a very long time until this fossil was found. And it's very rare to have this area down here become fossilized, but in this case, some of the soft tissues were imprinted into the rock along with the bones. And so in the end, you can see that this dinosaur had feathers, right? And so this is a big clue that it probably looked something like this, right? Weird looking bird, although it kind of does look like a turkey. Those turkeys that roam around and attack things with their big claws on their toes. They took the skull of this fossil and they put it in like an MRI machine to try to see inside of the bones. And they were able to see inside the skull. And like in the pictures before about the human skulls. By looking at the shape of the skull, you can tell about the shape of the brain. And modern birds have this bump down here that corresponds to their vision center. Because when you're flying super fast, it would be nice to have very good vision and fast reflexes. And so their brain has evolved to have this special spot. When they took the Archaeopteryx skull and they analyzed the inside, they found that that skull also had that part of a brain. And so, as always, this is just a theory. This is the idea. We have evidence to support it. This doesn't prove that Archaeopteryx could fly, but it does show that it has a brain that has a part on it that modern birds use to help them fly, right? And so the connection helps to support the idea that birds came from dinosaurs. So the birds, the Tiktaalik, and then the whales are all examples of how fossils have helped us to understand the past. And hopefully that makes sense to you. If not, make sure to shoot me an email or Google Hangouts or something like that. The end.